What is atomic radius? Atomic radius is one-half of the average distance between the two covalently bonded atoms. For example, the average distance for chlorine molecule is 1.99 angstrom. Thus, the atomic radius of chlorine is 0.99 angstrom. Atomic radius depends on two major factors. First, its effective nuclear charge, or we call it as ZEF. Second, its shielding effect, or we call it as screening effect. What is effective nuclear charge? ZEF is the net positive charge experienced by an electron in a multi-electron atom. Why the term effective is used? This is because the higher orbital electrons were prevented by the shielding effect of negatively charged electrons from experiencing the full nuclear charge. We must know that ZEF corresponds to the number of protons in a nucleus. Hence, the nuclear charge pulls all the electrons closer to the nucleus and causes the atomic size to decrease. Effective nuclear charge can be calculated. So here is the equation of effective nuclear charge on an electron. ZEF equals to Z minus F. For making it clear, ZEF equals to proton number minus number of inner electrons. How do we calculate ZEF? Here is an example of sodium atom. As we know that sodium has 1 valence electron and 10 electrons in the inner orbital. The nuclear charge of the sodium is positive 11, and the inner orbital charge is negative 10 because it contains 10 electrons, and effectively neutralizes 10 of the positive charges of the nucleus. Net positive charge felt by the valence electrons is ZEF equals to 11 minus 10. Therefore, ZEF equals to positive 1. Now, let's go through about shielding effect. What is shielding effect? Shielding effect describes the decrease in attraction between an electron and nucleus in any atom that has more than one electron shell. It's caused by mutual repulsion of electrons for each other. When the number of electron shells increase, the shielding effect experienced by the valence electrons will be greater. We must know that when the attraction between the nucleus and electrons is strong, the nucleus pulls the electrons tighter, while when the attraction between the nucleus and the electrons weakened, nucleus pulls the electrons less tighter. The electrons that are in the same orbital cannot shield each other effectively. Why? This is because they have the same average distance from the nucleus. Therefore, the electrons in 3s orbital doesn't shield the 3s electrons. For example, 1s orbital electrons of beryllium atom can shield the 2s orbital valence electrons from nucleus attraction. So now, what does transition metal mean? Transition metals are the elements which has a partially filled d subshell. The table and graph below shows the atomic radius of the d block elements. According to the table and graph I've shown just now, we can see that the d block elements show little variation in atomic radii compared to period 3 elements. From scandium to zinc, number of protons increases, and inner 3d subshell is added with an additional electron. Additional inner electrons are able to shield the outer electrons from nucleus. It's resulting in only a small change in the atomic radii. Hence, the effective nuclear charge does not change much. Lastly, the effect of an increase in the number of protons in the nucleus are cancelled out. Now, let's relate the ZEF and shielding effect by using titanium atoms as an example. When across the period of the first row of transition elements, the electrons are gradually added to the unoccupied 3d subshells, since electrons have occupied in valence 4s electrons. The proton number increases. The electrons in 3d orbitals shield the valence electrons in 4s orbital. The shielding effect to the 4s electrons also increase. Increase in the ZEF effect is cancelled by the increase in the shielding effect. Now, my explanation about the variation of atomic radii across the first row of transition elements ends here. Thanks for watching.